Hello friends, welcome to MATLAB School. In this simulation, we are going to simulate the control of induction motor with 3-level NPC inverter. So let us get into the simulation part. Uh, Now I'm going to simulate the output of squirrel cage induction motor drive with the help of MATLAB Simulink, and the reference speed that I'm going to give to this motor drive is 1000 RPM. And to this 1000 RPM, I'm comparing the actual speed. The output of this speed error is given as input to the PA controller. Then output of PA controller along with the actual speed will be added, and that will be given as input to the next stage. Okay, right. So basically this model is designed based on VBF control. Uh, at any speed, the ratio of voltage and frequency will be maintained constant. Uh, so this is the speed input which is given as input to the motor drive. Here what we are doing is just we are converting the speed to equivalent voltage. The voltage has to be in the range of 0 and 1. The maximum range that we give to this three-phase sine generator should be in between 0 and 1. 1 corresponds to maximum magnitude and 0 corresponds to 0 magnitude. Okay. Uh, then here at the other input side, we are converting the speed to frequency. So here we are using two conversions. To convert speed to voltage, we are going with this conversion 1 by 1300, because 1300 is the maximum speed of this motor. The reason is the motor's frequency is 65 and the number of poles is 6. So number of pole pairs is 3. So obviously the number of poles will be 6. So for this speed, for this poles, number of poles, and for this frequency, the maximum speed would be 1300. That we get from the formula ns is equal to 120 f by p. Okay. So through this leg, we are giving the frequency. Since the maximum frequency is 65, we are just converting the maximum frequency to speed to in the range of 0 to 65. Then the output, this three-phase sine generator will produce three-phase signal based on the input that it gets as magnitude and frequency. So the output, three-phase output, will be given to the next stage. In the next stage, we have the control PWM generators. So as you know, a NPC inverter will have 12 switches. Okay, you will find 4 switches in a leg. So on the whole, the number of switches would be 12. And to the NPC controller, we have this diode arrangement, capacitor arrangement. So to get the neutral point, we are taking the signal or taking the supply from the center point of these two capacitors. Okay, so here the capacitor used is having the value of 490 microfarad. Also, this capacitor is having the uh, value of 490 microfarad. Okay, right. Again, we have LC filter here, and the output of LC filter will be connected to the motor input. Okay. Also, the DC input given to this NPC inverter is 1200 volts, DC volts. So as you know, to drive the inverter switches, we are taking the output of these PWM generators So either we can go with this technique or we can go with the PWM generator which is available in the assembling library of MATLAB. Either you can go with that or we can uh, construct PWM generator in this way. Okay, so here the PWM block that I have used is having the frequency of 15 kilohertz. Right. So what is happening here is uh, the output speed of induction motor is sensed and it will be compared with the reference speed. Error will be given as input to this PA controller. Then this PA controller's output will be given to the next stage. Okay. So the main thing here is we need to tune the PA controller. The gains of this PA controller plays a vital role in stabilizing the output of this induction motor drive. Let us run the simulation. Okay, the simulation has started. Okay, yes, the speed is increasing. So the speed is settling around 1000 RPM. Okay, yes. Here, as you can see, it has reached the speed of 1000 RPM. Okay, so it will take a while to reach its maximum value. As you can see at point 9 second, the maximum speed is reached or the reference speed is reached. Like this, you can vary the speed as well. Okay, yeah, even we can have a step input. So to have step input, you can just type step. Step time we can have it as 1. Initial value we can have it as 1000, and the final value we shall have it is 1200. Okay, so the value will be stepped from 1000 rpm to 1200 rpm. So the total time we shall have it as 2 seconds. Yes, the stepping will happen at the first second. Okay, let us run the simulation. I'm running the model in accelerator mode. See, in accelerator mode, the speed will be somewhat faster than the normal mode. This the simulation has started. You see, it is running now. So when the time is equal to 1 second, you can see the step. So it will step to 1200 volt, 200 RPM. Yes, yes, there are some oscillations, and now it is setting exactly at 1200 RPM. is by fine tuning the PA controller, or by using fuzzy logic controller, or by using model predictive controller, we can reduce this overshoots and undershoots. Yes, it is setting perfectly at 1200 RPM. So the same model is available for download in the link given in the description. If you want, you can download it and you can use it for your purpose. Thanks for watching the video. Please share and do subscribe our channel. Thank you.